Types of functions. As you recall from our previous discussions, we've already established what a function is, how it takes elements from one set, called the domain, and relates them to elements in another set, the codomain. We've seen how functions create specific relationships between these sets. Now, what we're going to do is dive a little deeper. Not all functions are created equal. They can have different types, and these types are determined by specific characteristics or properties that the function possesses. Think of it like this. These properties essentially describe how the elements in the domain are mapped or connected to the elements in the codomain. Does every element in the domain have a unique partner in the codomain? Does every element in the codomain have a partner from the domain? These are the kinds of questions we'll be answering. Over the next few slides, we're going to focus on three main types of functions. These are incredibly important concepts that you'll encounter frequently in higher-level mathematics. They are injective functions, also known as one-to-one functions, surjective functions, which are also called onto functions, and finally, bijective functions, which are functions that are both one-to-one and onto. So let's move on to the next important concept in functions. We'll explore each of these in detail, learning how to identify them and understand their unique properties. So, let's start with the first one, injective functions. Injective functions, one-to-one. So let's move on to the first specific type of function we'll be looking at, injective functions. As we discussed on the previous slide, remember we're categorizing functions based on how elements in their domain map to elements in their codomain. An injective function, which is also commonly called a one-to-one function, has a very specific property. It states that each element in the codomain, that's the set of possible output values, is mapped to by at most one element from the domain, which is the set of input values. Let's break that down. Essentially, what this means in simpler terms is that no two different elements in the domain can ever map to the same element in the codomain. If you think about it, each input has to have a unique output. Now, how do we actually check if a function is injective? Well, here's a little test. Assume we have two elements, let's call them x sub 1 and x sub 2, both belonging to the domain, which we're representing as set A now. If the function, which we're calling f, applied to x sub 1 is equal to f applied to x sub 2, then it must be true that x sub 1 is equal to x sub 2. Think of it this way. If two inputs give you the same output, they must have been the same input to begin with. If this condition holds true for all possible pairs of elements in the domain, then you know the function is injective. Let's look at an example to make this clearer. Let's define two sets. A equals the set containing the numbers 1, 2, and 3, and B equals the set containing the letters A, B, and C. Now, let's define a function f that maps elements from A to B as follows. F of 1 maps to A, f of 2 maps to B, and f of 3 maps to C. If you look at this, you'll see that this function is injective. Notice that each element in set B, A, B, and C is mapped to by only one element in set A. There are no duplicates. No two elements in a map to the same element in B. Now let's look at a function that is not injective. Let's define another function, g, that also maps from A to B this time. G of 1 maps to A, G of 2 maps to B, and G of 3 maps to A. See what happened there? Both 1 and 3 map to A because two different elements in the domain, 1 and 3, map to the same element in the codomain. This function is not one-to-one, meaning it's not injective. Keep this concept in mind as we move on to surjective functions, because understanding injective functions will be crucial when we discuss bijective functions, which combine both of these properties. Surjective functions, onto. Let's move on to the next type of function, surjective functions. As we discussed on the previous slide, functions map elements from a domain to a codomain. Now, a surjective function, which is also called an onto function, has a specific property relating to how much of the codomain gets hit by the function. Essentially, a surjective function ensures that every element in the codomain is mapped to by at least one element from the domain. Think of it like this. If you're throwing darts at a dartboard, the codomain, A surjective function means every single spot on the dartboard has a dart in it, or at least one dart. It's okay if multiple darts land on the same spot, as long as no spot is missed. Another way to put it is that the range of the function, that's all the actual outputs you get, is equal to the entire codomain. So how do we check if a function is surjective? Well, for every element, let's call it y, in the codomain, which we'll denote as set B, you need to be able to find at least one element, let's call it x, in the domain, which we'll denote as set A, such that when you apply the function f to x, you get y. In other words, f of x equals y. If you can always find such an x for any y in B, then the function is surjective. Let's look at an example. We have sets A and B, where A contains the numbers 1, 2, and 3, and B contains the letters A, B, and C we define a function, h, that maps A to B as follows. 1 maps to A, 2 maps to B, and 3 maps to C. In this case, the function h is surjective. Why? Because every element in B, A, B, and C is mapped to by an element in A is mapped to by 1, B is mapped to by 2, and C is mapped to by 3. The entire codomain B is covered by the range of the function. Now let's look at a function that is not surjective. Again, A is 1, 2, 3, and B is a B, and C this time, we define a function, k, that maps A to B as follows. 1 maps to A, 2 maps to A, and 3 maps to B. Notice something? The element C in the codomain B is not mapped to by any element in the domain A. There's no x in a such that k of x equals C. Therefore, this function k is not surjective. Remember, for a function to be surjective, every element in the codomain must be hit by at least one element from the domain. Keep this in mind as we move on to the next slide, where we'll combine these concepts and look at bijective functions. Bijective functions, both one-to-one and onto. Let's move on to the final type of function we'll be discussing, bijective functions. As you can see from the slide, a bijective function is simply a function that possesses both the properties of injective and surjective functions. Remember, we just learned that an injective function, or one-to-one function, ensures that each element in the codomain is mapped to by at most one element in the domain. And a surjective function, or onto function, ensures that every element in the codomain is mapped to by at least one element in the domain. So, a bijective function combines these two. This means that each element in the codomain is mapped to by exactly one element in the domain. It's a perfect pairing, nothing is left out, and nothing is duplicated in terms of mapping. Let's look at an example. We have sets A and B, where A contains the elements 1, 2, and 3, and B contains the elements A, B, and C. We define a function, let's call it m, from A to B as follows. M of 1 maps to A, M of 2 maps to B, and M of 3 maps to C. This function is bijective. Why? Well, it's injective because no two elements in a map to the same element in B. Each element in B is uniquely paired with an element in A. It's also surjective because every element in B, A, B, and C is mapped to by an element in A. Now let's look at a function that isn't bijective. Again, A is 1, 2, 3, and B is A, B, C. This time, we define a function n from A to B where n of 1 maps to A, n of 2 maps to A, and n of 3 maps to B. This function is not bijective, and it fails on both counts. It's not injective because both 1 and 2 map to the same element, A. Remember, for injectivity, each element in the domain must map to a unique element in the codomain. It's also not surjective because the element C in B is not mapped to by any element in A. Now, at the bottom of the slide, we have a quick recap of the key takeaways. Injective means at most one, surjective means at least one, and bijective means both. Finally, let's quickly go over some common mistakes students make. It's easy to get injective and surjective mixed up, so remember the focus of each. Injectivity is about unique mappings from the domain, and surjectivity is about covering the entire codomain. Also, don't assume a function is bijective just because it's injective or surjective. You must check both properties. And importantly, when checking for surjectivity, make sure you check that every element in the codomain is mapped to. Don't get so focused on the mappings themselves that you forget to verify that nothing is left out. All right, That covers all three types of functions. Make sure you understand these definitions, as they're fundamental to many areas of mathematics.